Welcome to this latest episode of Nerding Out with Viktor. Today, we're diving deep into the exciting world of 5G and 4G technologies with a special focus on open source innovation that is reshaping the telecom industry. Our journey will take us through cutting edge projects like Magma and SD-Core. I'm thrilled to have a distinguished guest with me today, Guillaume Bélanger from Canonical. Before joining Canonical, where he now leads the 4G and 5G management of private networks and projects, Guillaume honed his expertise at Bell. His expertise and insights are invaluable in understanding how open source is influencing the evolution of 4G and 5G networks. So gear up for an exciting conversation that promises to deepen your understanding of these technologies and the impact on the world around us. So welcome to the show, Guillaume. Very excited to have you on the show.
Thank you, Viktor. Thanks.
Did a quick intro. Is there anything you would like to add to that intro to help listeners better understand who you are and perhaps the vantage point you're coming from?
Yes, of course. As you mentioned, I'm working at Canonical. I've been here for 2 years now. I'm engineering manager leading our 5G private mobile network offering. So the way Canonical works typically is that we work closely with upstream community, and we work at automation and packaging of that software to make it as easy as possible to deploy, but more importantly, to conduct all the lifecycle operation of that software. So here I'm talking about scaling, upgrading, and integrating with observability and other necessary components that you may have in your infrastructure. And I'm happy to answer any other question you may have.
Perfect. Let's dive into the whole packaging side of things later on, because I think that's kind of interesting, and I kind of want to dive into that as well. But the reason why I wanted to do an episode on 5G and 4G and LT and all these technologies, because I think we're at almost like a pivotal moment right now with the evolution of 5G, where I think 5G might possibly be the new Wi-Fi if you fast forward 10 years out. And I think the big game changer, at least for me, and what I got really excited about is with eSIMs, because with eSIMs, you're no longer locked into a singular carrier. So you can have three. I've had three SIMs in my phone for a while, and you can now use MVNO, so mobile virtual network operator, that can serve a specific niche. They don't have to have a countrywide coverage. They can have super good coverage in a small area you're in, perhaps, or even a coffee shop or so on. So I'm just wanted to pause there and say, like, does this kind of, how do you see this? Is this as something that you would agree with as a thesis, or how would you basically see this world shaping up?
Yeah, well, it's hard to tell, and it's always hard to predict the future in those areas. 5G and Wi-Fi at the moment serve different purposes and
Yes.
are very much a set of different technologies. And 5G, the way it's a set of spectrum. So here if we talk about the air aspect of it, and each country has their own ways to acquire part of that spectrum, and it costs a lot of money for any given company to have access to that spectrum. There's also a set of licenses that are required if you are to implement your own 5G radios. That you would have to pay to a company like Qualcomm. At the end of the day, this means that operating 5G is much more expensive than operating Wi-Fi. So this is something that has to change over time if we want to get closer and closer to Wi-Fi in terms of cost. That being said, I mean, they both serve. There's also lots of commonalities between the two. Like, at the end of the day, the goal is to go have access to the internet, and most people don't really care about how they gain that access as long as it's the cheaper and reliable option. So it's definitely a possibility, but I see a set of things that need to happen in order for us to be there.
Yeah, I mean, the legal part is obviously a massive part of 5G in general. I think in the US is probably leading the way with the CBRS spectrum, where you can deploy without having these licenses. I'm not sure you want to speak a bit about that and just enlighten people on what that means and how that kind of what that means for someone who wants to deploy a 5G route, a private 5G, for instance.
Yeah. So in the US, CBRS stands for Citizens Broadband Radio Service. So it's a somewhat new service that the US has been starting. It's around 5 years old, but very much implementation is starting like in the past 2 years. And the main idea, so I spoke about spectrum earlier, and the main idea here is that if you have your own private mobile network company, you don't have to purchase spectrum. That's a huge deal because if you look at spectrum costs in the US, it's in the hundreds of millions of dollars for just a small band for a given geography. So most people, most company cannot even dream of purchasing a part of that spectrum. And the idea of CBRS is that you can use part of that spectrum without purchasing it. So the way it works is you have companies that work with the FCC in the US. That's the regulatory body that owns those processes. And those companies so Google is one of them, for example, and they have a service called a Spectrum Access Service. And if you want to use those bands, you have to integrate with this service, and they will tell you exactly which band you are allowed to use and when, and then you can integrate with that. This is groundbreaking in the sense that it is completely new. It's the first and only country, as far as I know, that has such a system. And the main outcome, hopefully, will be that a reduced cost in operating 5G. This is huge. I don't know if other countries are going to follow through. In Europe, there's been some bands that have been allocated to specific companies. I think Daimler and a bunch of others did purchase some small part of the spectrum, but there's no such system where any company can just operate their own 5G network. That's really exciting.
Yeah, I think there've been some pilots. I think Sweden, among other countries, had some kind of pilots where you could apply for a very small, like building level spectrums, so the right to use a spectrum within a given building or a campus. But yeah, it's not something you could deploy across a country, for instance. But they will be like a much reduced price, then obviously, and kind of fits into the narrative that maybe your office would offer or college would offer a 5G service rather than just Wi-Fi, and because those would be far cheaper and far more efficient to achieve. So let's dive in a little more to like the status quo before we dive into the open source world. I'm curious about, you talked about these extreme costs for the spectrum, but the spectrum is one part of it, important part obviously, but talk a bit more to me about the hardware setup. How does a AT&T or a Bell or insert blank carrier, how do their infrastructure look like for the end user, or like end to end really?
Yeah, sure. So when we talk about 5G, we talk about two different parts. We talk about what is called the core network and then the radio network. I'll start with the core network. So the core network is the part that most people typically don't know about. It's not a well-known aspect of 5G. And this core network is very much the equipment and logic that makes your 5G network function. So in this part of the network, you have all the logic related to authentication, authorization, charging, policies. So it is more or less software that runs on a computer. So in terms of hardware, you need computers. It's very much as simple as that. As we get closer to the radios, one component of that core network is called the user plane function. So this one is the component part of the core network through which user traffic goes through. So this one, when you make any usage of your cell phone, the packets that go out of your phone will go through this function. So this one, typically you would have a bit more specialized hardware in order to minimize the latency and time that packets need to be processed in this component. But for the rest of the core network, it's just generic computers.
So in the user space, that's where the traditional telco vendors are, like Ericsson, Nokia, Huawei. That's where these guys have a significant market share, right? Correct. And then I guess the control plane, is the other side. Is that fully standardized, or like every kind of carrier roll their own system, or how does that look right now?
Okay, so historically, it used to be that companies, the examples that you mentioned, would sell you physical hardware to install. So they would call a company like BT or Bell Canada, and they would install those boxes, physical boxes there. Now with 5G, the code itself, like the software itself, is based on specifications written by 3GPP. So what Nokia, Ericsson, and others do is they will implement those standards. So it is fairly standard in that sense that they have to, well, they don't have to, but they follow those standards. What changes is, even though they do write implementation of such standards, they also have other integrations that are not part of these standards. An example of this is what they call their network management system. So 5G is a set of different functions, something like 12 different network functions. If you want to configure those, you would typically need either a user interface or a set of APIs to do so. So those companies will sell you this network management function. They will, and that's how they make money at the end of the day with those integrations. You don't just buy a generic network function. You buy a platform that comes with monitoring, that comes with a nice UI to configure it. And more importantly, it comes with 24/7 support from them. If your network crashes, you have somebody to call for help.
Right. Okay. Okay. So that's the status quo. Before we dive into kind of the nitty-gritty details of what this all means, I'm curious about going through some different type of terminologies that some of them already been mentioned, but just for clarity before we dive into the details. So we already covered 5G and the fact that it's actually a family of protocols rather than a singular protocol, right? So we can dive into that a little bit. Do you want to say a few words about what those standards are? Because you already alluded to the fact there's an IoT version, there is a regular mobile version, but then there are other families as well, right? For other use cases. Do you want to zoom in a little bit on that?
On 5G specifically?
Yes. Let's start with the 5G part.
Yeah, sure. So, I mean, 5G, I mentioned earlier the core network. So like 5G is a set of network functions and communication protocol that those network functions should follow to communicate together. So that's for the core network. 5G is also the set of frequency on the radio side and the protocols on the radio side that have to be followed between the radio and the modem on your cell phone. So 5G is all of that. So it's more than just one specification. It's a set of specifications that companies and implementations have to follow.
Yeah. So you have, okay, that makes sense. Let's talk more about the specific ones, because I think one thing I didn't know about was particular about the lower consumer cases like the IoT versions for 5G, for instance. How widely? I mean, I know there's a standard for it. Is that something that's widely deployed today, or is that something that is just a theory or a protocol designed by GSMA? I presume it is. Or how is that actually? Yeah. Do you want to talk a bit about that? Because I'm curious about those use cases.
The truth is, I'm not familiar with this. I'm not sure what's the IoT specific standard for 5G. So you may be more.
There's a low energy concept for 5G essentially to compete more with LoRa for lower energy consumption. So low bandwidth, higher range, and low energy consumption. But yeah, that's fine. We can skip over that part. That's fine. 4G and LTE are obviously different generations and different type of end user communication methods to the towers. Do you want to differentiate between the two of them and talk a bit more about what they are and how they are different?
Yeah, so for each of the generations of wireless communication, there is a set of standards that define both the core network and the radio network. 4G had its own set of components that are part of a mobile network, and LTE was an evolution to 4G that was compatible with 4G that introduced some new components. For example, the one part of that, one of those components was called the EPC, the Evolved Packet Core. So it was an evolution of 4G. 5G itself is a completely new design, a completely new set of functions and functionality part of that core network. And if you were to implement 5G, the core part, you would have to do it from scratch.
Okay, so LTE is basically 4G, 4.5G, essentially. It's in between 4G and 5G, essentially, for higher throughput. Yeah. Got it. Okay, cool. One thing that pops up a lot when doing research about this, and it's something that spans all network technologies, is SDN, like software-defined networking. That's a big concept. How far is that being pushed on this? Because I know on switch level, like on server side, like that's kind of commonplace these days. But how far is that deployed and used in this context here?
Yeah. Yep. So as I mentioned earlier, it used to be the case that you were to purchase a physical box from a company that would take the role of a given network function. If we talk about 5G now, what you are purchasing from those companies is essentially software that you will install on generic hardware. So you would very much buy a server from a company like HP, Dell, or whatever company you prefer, and install your 5G network functions from Cisco, Nokia, or whoever on those physical boxes. In this sense, it is software. Now, not all of those components that are part of 5G network are only software. Some of them need to be, like I said, hardware accelerated earlier. So software defined is very much like a trend that instead of buying physical boxes for something, you write software and you install it on boxes. For routers and switches, it is still the case that a physical switch is faster than a software switch.
Yeah.
But depending on your use case, that may be fine. It really depends on what you're trying to achieve.
How about SDR, software-defined radio? Is that something that entered the space as well, with like where you can redefine the spectrums basically in software using sophisticated silicon, really, right? So, or sophisticated hardware.
Yeah, that's getting more and more popularity. I mean, even if you take like Qualcomm's offering in the world of radio, it is very much software defined. So for the world of 5G, there is something called Open RAN, where it is a set of specifications that you would implement. So you would write code that satisfies those implementation, and you would and that code can run on generic hardware. So you can have an Intel chip, or you could have a chip that is actually made specifically for that purpose. Software for radio is a trend in the industry where you can write code on that radio. And there's more and more like smaller projects that are like you could yourself buy such a radio and write code on it for yourself. There's a project, for example, called Blade RF that is exactly in this space where you buy a radio for something like $500 and you use their project from GitHub and install it.
It's like a hack RF similar thing for radio. Got it. Okay, cool. Cool. One thing that you've mentioned a few times now is that it's becoming standardized, and it's like you're running on commodity PCs now, and obviously that is a nice transition over to the software side of things. And there are two projects that I kind of want to do kind of talk a bit about. One of them is Magma, and that one is SD-Core. Magma, if I'm not mistaken, is probably came out of Meta and has had a quick rise and a quick fall from what I gathered. Do you want to speak a bit about Magma, what it accomplished, what it accomplished, and why it failed in the end, really?
Yeah, sure. So yeah, Magma is, it's still out there. It's a 4G and 5G private mobile network that was led by Facebook at the time, and at some point Meta. So it started at Facebook, or actually it was announced by Facebook Connectivity in 2013. But the first commits showed up on GitHub in 2019. And most of those commits were made by Facebook employees. So this was very much led by Facebook. Now, in terms of why they were spending any effort on it, it's generally to increase connectivity in the world. And that next part is speculation, so that more people can install Facebook on their phone.
Right.
So now in 2022, there's been a huge round of layoffs at Meta, and they completely reshuffled the projects and focuses of the company, and the whole Facebook connectivity. So not just Magma, but every project under that umbrella stopped being funded. Now, to facilitate the transition, they did pay a firm in Germany to help with this transition. So they would continue the work for a specific amount of time for I think it was 1 year. But that funding stopped at some point, and in March 2023. And And at this point, it is a community-led project in the sense that Facebook doesn't spend any engineering effort on it. But the truth is, the amount of commit has drastically decreased.
Right.
I mean, now what brought this project to this situation? It's always hard to know for sure. I'm not behind the scenes at Facebook, but one thing that has to be said is that Facebook didn't make any money directly from this project. So
Right.
when things go rough and you need to find projects to cut, it makes sense from a business point of view to cut these categories of projects.
Yeah, that makes a lot of sense. Yeah, go ahead. Sorry.
And in terms of growth, I mean, Magma didn't. There's been a lot of excitement around Magma when it started, but for the last couple of years, I mean, the amount of users and companies implementing it didn't grow that much. So I suspect they felt that's a good time to let it go.
If I'm not mistaken, Amazon's 5G offering did use Magma at one point, I believe, their private 5G offering. Maybe you have more insight to me than on that one.
Yeah, well, supposedly all of that is not public, so I don't know for sure what they did use or they're currently using. This could have been part of a exploratory phase or actually implementation. Right. I don't know more.
Okay, fair enough. Yeah, because obviously, had they pushed ahead there, they could obviously have the manpower to and revenue stream to actually maintain such project, right? They would have much bigger incentives than Facebook.
Yeah.
Cool. Let's talk about SD-Core, which is the new kid on the block. It sounds like, well, maybe not new, but what has taken over a lot of the traction from Magma, from what I gathered.
Yeah. Well, so Magma was or it still is a 4G and 5G private mobile network. So it is a set of technologies that are bundled in a package. As of SD-Core, and also another implementation that comes from an European organization called OAI, Open Air Interface, those two projects aim to be much closer to the actual 5G standards. So those are actually like you read the 5G specs and you implement them in code. They don't do much more than that.
Right.
This is both a pro and a con. It's a pro in the sense that it is really following the specs. You can be pretty confident that it is compatible with anything else that is also following the specs. But Magma was trying to be more than that in the sense that it also contained a nice user interface and integration with, earlier we spoke about CBRS. Magma came with integration with spectrum access systems. All of those that are not necessarily part of a 5G specification. Now, SD-Core is a project led by the Open Networking Foundation, and it is an implementation of 5G core specification. So all of the network functions that are part of 5G core, so those 12 or so network functions, are being implemented in Go code, and us, like Canonical as a company, we package and distribute those as well.
Okay, so what in terms of deploying your own? Because I know there were like a Juju deployment mechanism for Magma, for instance, which I presume is kind of dead in the water now, or it might go into maintenance mode, I would imagine. Has the offering around SD-Core replaced that from the Canonical's roadmap in terms of what you guys are pushing on your end, or how do you guys see the world there?
Yeah, we're in the process of doing that. This is the type of project that takes a while, but yes, we are in the process of doing this. We are also involved in the actual upstream project. So we work with the upstream community to improve the actual software that is distributed, and we also package it and distribute it to make it as easy as possible to operate. So if you are to follow the upstream deployment of the project, this is done through Helm charts on Kubernetes, and it works. What we are trying to offer here is a more universal way to deploy SD-Core. For example, in the upstream project, you only there's only one distribution of K8s that is part of this like deployment script. In our case, we we have compatibility with any cloud Kubernetes. So if you're using
Right.
AWS's Kubernetes offering, or if you're using your own personal micro-K8s on your laptop, both work with this approach. If you want to scale and upgrade, we offer those paths as well.
Okay.
Yeah.
So speak to me a bit more about, like, if I wanted to deploy my own. Let's assume for a second that I am in the US, because it makes decisions a lot easier around CBRS, and you have your own. You can use a CBRS spectrum. What does it take for me to set up my own 5G network at home, if from scratch, if I wanted to run my own? Like, imagine for a second I live in the middle of nowhere. I have Starlink, but I have zero connectivity, right? So I want to set up my own 5G network at home. Walk me through how that would look in terms of like end to end.
Yeah, sure. So from the core network, so the part of the story, you would need a computer. And if it is just for yourself, you would very much be okay with something like Intel NUC, or just a really small computer that has a relatively modern CPU in it. And this computer would run all of your 5G core network. Now, you would also, so on this computer, you would install ideally a Linux distribution, and you would install Kubernetes on top of it. And you would use something like a Juju, but not forced. You could use also Helm or something else to both deploy and operate your 5G network. So all you need is this one computer on which you install this software. That's for the core network. Now you also need a radio that you would buy from a radio vendor. Those tend to be a bit more expensive. That we were talking about cost for 5G a bit earlier. You would have to spend between $1,000 and $20,000 for such a 5G radios. Those are quite expensive, depending on if it is outdoor, indoor, and the specific technologies that are in this radio that would vary. But those are essentially the two things that you need. It is the core network is going to be pretty cheap in this story. Very much, you're going to spend most of your budget on this radio equipment.
Right. And then, okay, so I have the software stack installed. I also need to connect my phone, right? So walk me through the process of, I guess, issuing eSIMs or SIMs, bootstrapping. Like, how does that process look like if you want to run your own infrastructure?
Yeah. For physical SIM, you would need to have a SIM writer, so a small piece of equipment that can write SIM cards. And on your core network, you would have to register, okay, I have this new SIM for this new user. This is the set of policy that I want this user to follow. For example, I could give you a 20 megabits per second speed with a certain priority. So there's a concept of priority in 5G and 4G, which decides like, okay, well, when this person and this person talk, this one has priority, or that's the type of stuff. So yeah, you would need to write that SIM and register it in your core network, and install this SIM in your phone, and you should be good to go. That's for SIM. Now for eSIM, the story is a bit more complicated. I haven't worked much with eSIMs yet. This is still to go, still to come. But it depends, from what I understand, on what is your cell phone. For example, the process of becoming a carrier of eSIM on an iPhone versus on an Android phone is different. With Apple, as far as I understand, you need to be somewhat of a partner with them. So I cannot go on my own and become a 5G carrier. For Android, it seems a bit more straightforward. But like I said, I haven't gone through this process for either of those, so I'm not certain of this process.
Okay. And then I guess you have some kind of serial number that from the SIM card, I presume that, or how's, like, what's the cryptography of this? Like, when you write that SIM card, like, is it a private key that goes on there and the public key that you register, or like, what does the cryptography side look like?
Correct. It's a publicly private key system where you would, it's exactly that at the end of the day. And whenever you register that SIM card on your core network, you would register its public key. So both sides have a public and private key.
Right.
So it's very much, it's not so different from any HTTPS communication.
Right. So it's basically like a small local PKI, essentially, that you can. Okay. So And are there like CLIs for this, or like is it all API based, or the UIs for like if you wanted to build this yourself? Like, what does that look like in terms of experience?
So on the core side, to add and register SIM, so this part is very much not part of the 5G specification. So each
Okay.
company implements their own approach to subscriber management. But if we talk about our distribution of SD-Core, like we write our own network management system, where you can create network slices, create device groups, and create subscribers. And so it is a front end written in Next.js that people can use to configure their network. So yeah, it is a pretty nice front end with this purpose. Now the process of writing SIM cards itself, there's companies that sell their own SIM writers. I don't know of any nice open source project there. There is some really smaller projects. There's something called PySim out there, which comes with a CLI to help you write SIM if you have a SIM writer. I haven't worked with it yet. Yeah, this part is, I think people will tend to go directly to eSIM, but there needs to be a bit more of an like open source approach to it, which likely will go through Android before Apple.
Right. So it sounds like it's not super straightforward given the state of the project today to like build your own 5G network in your house. It requires obviously hardware, but that's inevitable, I guess, for the time being. But well, forever, I guess. But cost wise, I meant. But there are like, how do you like? Do you because it is like, is it kind of proof of concept level quality, or is it like stable production level? How do you rate like the stability or maturity, I guess, of this?
Yeah, today I would call it like an MVP. Like you could deploy
Right.
it. You can use it to run subscribers. I would discourage you from running high like supercritical load on it. Like I would very much discourage you from using 911
Right.
calls on this network. It's still in early stage. We started working with SD-Core a couple of months ago, so it's still very early development phase. Um, but as we go through like user validation, we will gain feedback and improve the product for sure.
Cool. So we talked about before we turn the table to some other things later on, but before we do, I'm curious about, we talked about data routing, and that's obviously very similar to like network routing in general. How about phone call routing? How does that work? How does like, because that's usually tied to your SIM card and you usually get an identity there. How does that whole interface with the rest of the world? I have my own interface. I can run network data, but what if I want to actually make phone calls? Like, how do I actually register that, and how would that actually work?
Yeah, you would need to. So yeah, here we only touch about the SD-Core really does only the data part. So we
Okay.
haven't yet worked on this phone aspect of it. Again, is the type of projects that is going to come up fairly soon. But right now, you would need to integrate with a mobile network operator's system for managing those phone calls. So yeah,
Okay.
coming up, but not currently possible.
Got it. Okay. So obviously this is very much in the research phase of where you are at Canonical, how you see, and obviously a strategic bet, obviously for the future. Talk to me a bit more about how you see private 5G being deployed in the conversation you guys are having with and who's actually interested in this. Like, is this like companies and campuses that are mostly interested in these conversations, or are there conversations with mobile carriers that are looking to deploy this as well?
Yeah. So those are two sides of the coin for us in terms of private 5G. So for companies, there's a bunch of factories that are interested in having 5G mines or rigs anywhere that is typically poorly served, or that you want isolation from the rest of the world in your 5G network.
Right.
Those are all potential customers, and they're good use cases for us in the sense that in terms of it's not running critical infrastructure like the I mean, it's not a hospital.
Right.
But that being said, hospital are also good use cases for private 5G. And then there's private. Then there's mobile networks for mobile network operators. So a company like BT or Bell, they receive requests from companies that are interested in private mobile networks. Most enterprises don't necessarily have the skill in-house to operate such private mobile networks, which of course makes sense. But they want 5G connectivity, so they would call a company like Bell and ask them to run that for them. So it is a case where Bell Canada would spend much less money by running a private mobile network than running their more like country-wide grade 5G network. So those two cases are possible for private mobile network.
Right. And yeah, that all makes sense. And in terms of architecture, I the actual antenna piece, I guess, is a network connected device. Can that then just talk to some cloud interface, or is latency so important that you need to have all the other pieces on site as well? Or how does that infrastructure look like for something like this?
So for some part of the system, latency is super important. So the antenna will typically talk to the component I talked earlier about called the user plane function. And this user plane function will be close to those antennas, physically close.
Right.
Not necessarily. And then that physically close number, it depends on your use case. You may want it to be in the same building. You may want it to be in the same city. That depends on your latency requirements. And then the rest of the core network is not going to impact latency as much. So the rest of the core network is going to be responsible to tell the user plane function and the radio whether or not the user is allowed to use the network, and they're going to manage the session, but they're not going to impact latency as much. So part of it can just be on a cloud system. So most of the core network can run on AWS or Google Cloud. The user plane function will typically run closer, like maybe in your factory, and then you can have a couple of antennas in your factory that are linked through that user plane function with either fiber or Ethernet cable, depending on the load that you require.
Right. Do you see a world where AWS, Google, all these guys are essentially going to go head to head and compete with the traditional telcos because they have the infrastructure ability to run the control plane better so than the telcos would and have far higher scale and would do it more effectively and cheaply. Is that a scenario you see playing out, or how do you see the world there?
Yeah, well, it's a possibility. I know Google tried it a little bit. For some part of it, it is possible. I mean, most of the telcos are now going through a phase where they are moving a lot of their private clouds to the public cloud. So clearly, the public cloud is something that they don't currently have. However, a big part of operating a telco is laying fiber, cutting trees, and installing radios. And I don't see Google going in that direction. So most of that part of the work, I still see a place for telco. But for running servers, definitely a place for the cloud.
Yeah, no. And that's kind of like, like you said, Google played with that. I think Amazon had something they called curbside something, a service that I think they were using for some of their, was it Alexa that they use some backend as well? I think they use some of their devices to kind of create like a semi telco, but I think it was based on LoRa rather than 5G. But I think I'm not sure you've seen anything about that project.
I haven't seen it, but definitely. I mean, they're getting more and more in the space of telcos. They clearly all want the telco business. This is billions of dollars worth of money, but they are getting it. I mean, if you look at a company like Google, they are currently working on a project called Nephio, which is a open source automation project, and it's fully open source, but they work on these kind of projects to attract the telcos so that they run their workload on Google Cloud instead of another cloud or on their own private cloud. Telcos still have currently huge clouds to maintain, so thousands and thousands of servers that they run throughout the country to run those 5G network services, and clouds are more than happy take that workload.
Yeah, absolutely. I can definitely imagine that, and I think that's what like particularly with the commoditization of the infrastructure, and like if you can use things like if I'm not mistaken, I believe Google's home hubs, I believe they have a level of SDR in them where they can probably not do 5G perhaps, but you can envision generation 3 or 4 out where they would have support for this built into their home hubs, right? And then
Yeah.
it's definitely an interesting development. I think this is super interesting, and I think we've covered our grounds. And I'm not sure there's anything else you think it's worth bringing up in terms of the development and how you guys are working on, and what people can learn more, and how people can help develop and test this out themselves.
Yeah, so most of the projects we talked about are open source. So both enterprises, but also individual, can work on those. They tend to be really fun for university projects, the sense that people can work on their own during, for example, their master's degree, add some feature, and then having this feature merged at the end. Those are exciting for this purpose. And on the other side of things, what as a company we're trying to do is bring those to a step that they become actual products where you are confident to run high critical workloads. So, I mean, to learn more, you can go on the ONF website. You can look at Linux Foundation networking. You can look at Open Air Interface, or if you're really, really want it, you can read the actual 5G specs. But I suspect that's not free.
Yeah, and how far do you think Canonical, or you guys in general, are from having this as a commodity item, in the sense that just like you would deploy Kubernetes, you could deploy your own 5G stack? How far do you think that is away?
Very close. I mean, to run data, you can already do it. So this is it is a work in progress, and it's never going to be fully finished. But yeah, it's a matter of months, not a matter of years.
That's amazing. Yeah, I'm definitely looking forward to giving that a go, and hopefully the legislative side of things in Europe will make it easier. I'm not sure how things are in Canada, but I think it's in the UK. At least it's still difficult to get those approvals.
It's similar, and it's very much similar across the world.
Perfect. This has been super insightful for me, Guillaume. I'm very happy for you to have joined me on the show, and yeah, thank you so much for coming in there, and have a good one. Thank you so much.
Thank you very much.
Cheers.
Bye-bye.
Bye.